Alright, here we're looking at section 9.4 today. So our learning targets today, we're really going to be looking at the graphs of our sine and cosine functions. First we're going to look at some characteristics of them, then we're going to stretch and shrink them, then we'll be translating them, and then we're finally reflecting them. The big thing to keep in mind is how they're similar and kind of how they're different. So I want to just look real quickly at the graphs of sine and cosine. So here on Desmos you see I've graphed them both. The red graph is my sine function, and the blue graph is my cosine function. So you see, these are called sinusoidal graphs because it's just a sine wave. It just keeps going and going and going in this wave-like function. You'll notice that both of these graphs are very similar, and if we translate, which we'll look at in just a minute, you will end up with the other graph. So let's look at some of our characteristics. So the first characteristic is my domain of each function is all real numbers because that wave continues on in both directions forever. So the range of my functions is between -1 and 1, right, as we can see here. So here's the maximum value at 1, and it's the same for my sine function as well. My maximum is at 1. So my minimum functions are going to be at -1 for both my sine and my cosine. So my range would go anywhere between -1 and +1. Okay, so the amplitude, we have something about this called amplitude. So the amplitude of the graph is 1/2 the difference of the maximum and the minimum value. Okay, so if I take my maximum and my minimum, I figure out how far apart they are, and the amplitude is half of that. So what we have too is called a midline, and we'll get to the midline in a minute. The amplitude is the distance from the midline. Amplitude tells me how tall half of it is. So we can see that amplitude here. Let's on either curve really. So the middle, right, would be my x-axis here. So the amplitude tells me how far from the middle to the very top or the very bottom. Okay? So each function is periodic, which means that it has a repeating pattern. Okay? Each little part that we're looking at is called a cycle, and the horizontal length of that is a period. So each of these graphs, right, my sine and cosine, has a period of 2 pi, right? So and it's easiest for me to look at the period of a function going from the very top. How long does it take me to get back to the very top? And for both sine and cosine, that is 2 pi. And one way we can always remember that is if we're looking at a circle, to get from the top, go all the way around to the circle and end up back at the top, I've gone one entire revolution, which is 2 pi radians, right? So that can help me. So now our x-intercepts are a little bit different as well. So the x-intercepts for sine curve are at 0, and then plus and minus pi, and then plus and minus 2 pi, so we can see this pattern continue. Okay, so the x-intercepts for my cosine are plus and minus pi, 3 pi over 2, 5 pi over 2, 7 pi over 2, right? And we can continue that as well. You'll also notice that my y-intercepts are different. So for my sine curve, the red one, my y-intercept is 0, and for cosine, my y-intercept is 1. That's just a little change as well. So now let's look at amplitude and period and how we find those from our equation, right? So here I'm given an equation, a sine b of x and a cosine b of x. So my amplitude, right, that height is going to be the absolute value of a. So that a tells me the amplitude. The period, right, remember how long it takes me to get from the top back to the top, is going to be 2 pi, which is one entire revolution around a circle, divided by the absolute value of this b in either sine or cosine. So now let's look at some examples. So first we have to identify the amplitude and period of g of x equals 4 sine x. Then graph it and compare my graphs. Okay, so the first thing I want to do is I want to find the amplitude and the period. So my a is going to be 4, right, because that's out in front. My b would be 1 because I don't have any number in here with this x, so my b is 1. So my amplitude is 4, and the period is 2 pi divided by b, which is 2 pi. So now I can still find my intercepts, and I can use this to help me graph things, to find my maximum and minimum. So the big thing I should notice, right, is I'm dealing with the sine curve, so I know that I still intersect at those, at pi and 2 pi and 3 pi and those as well. The only thing that has changed is the amplitude, right? My amplitude is now 4 instead of 1, which we can see if we go into here. The only thing that has changed is the height of my graph, which now goes up to 4 and down to a -4. That's the only thing that's changed here in this graph. So let's look at our next example. Identify the amplitude and period of this function, then graph it and compare. Okay, so first thing I see is my a value is 1/2, my b value is 2 pi. So my amplitude is 1/2, and my period, I take 2 pi, divide it by b, which was 2 pi, which gives me 1. So now I know I'm dealing with the cosine function, so I can start with those intercepts, find my maximum and minimums, and see what I'm looking at. So here, you'll notice that your intercepts have actually changed because we've changed the period of our graph. Our graph is also shorter, right? It's not as tall. The amplitude is much smaller. So now I can graph that. So now instead of dealing in terms of pi down here on my axis, you'll see that I do one entire revolution. So I go from the top back to the top in 1, which is what my period is up here. So now here are some that you can try that you can't really see, but these are in your book if you want to actually look at them and try them. So now we're looking at some translations of our graph, right? And we've seen equations that look sort of like this before, like an x minus h and a k. Those variables do the same thing, okay? Our h is still our horizontal translation, and k is still our vertical translation. So when we're graphing equations like these, we follow these steps. First thing we do is identify the amplitude and the period. We look at the horizontal shift, right? The horizontal translation back and forth, which is h, and the vertical shift, which is k. So first we have to find those 4 main things. So then I draw my midline. My midline is going to be wherever my k value is, okay? So I draw that horizontal line, y equals k, which is the midline. So then I find my 5 key points to translate my graph, and then I draw my graph through those 5 points, okay? So we're going to look at some examples of that. So here I'm asked to graph 2 sine 4x plus 3. So the first thing I have to do is find the amplitude, the period, the horizontal shift, and the vertical shift. Okay, so I see that my amplitude is 2. My period, I take 2 pi divided by b, and my b here is 4, so my new period is pi over 2. I don't have a horizontal shift because I don't have anything in parentheses with my x, and my vertical shift is k equals 3. Okay, so now I have to draw the midline of that graph at this k value. Okay, and then I find 5 key points. So what I do is I go ahead and on this y equals k, I plug in some of my points and find these new points. So I find some maximum and my minimum, and then I draw my graph, right? So I have to find a maximum and a minimum and 3 intersection points, right? That's what we're looking at here, okay? So the easiest way to find these intersection points is we know what one period is, right, is pi over 2. So I see I start at the midline, I go up, then I go down, and I'm back to the midline. So I know I need to find both of those points, and then I can find the one that's directly in the center, okay? And then I know that my maximum and minimum are going to be between those 2 points as well. So that can help me narrow down my x values that I'm going to use to find these points. Okay, so now here's our next example. Graph 5 cosine of 1/2 times the quantity x minus 3 pi. So first, again, I have to find my amplitude, period, horizontal shift, and vertical shift. The amplitude is at a value, which is 5. The period is 2 pi divided by b, which it gives me 4 pi. The horizontal shift is 3 pi, and I don't have a vertical shift here because there's no k value out back here. So now I next have to draw the midline. So when k is 0, the midline is going to be my x-axis. So then I find my 5 points. Okay, so I know that I am dealing with the cosine function, so I can kind of start with that. I can plug in some x values, right? So I'm going to use pi plus 3 pi, which is this h value, and then 3 pi plus 3 pi, right? And I get those from the intersection points that I've already looked at being common in my graphs. Okay, so I come up with those 2 extra points. I find my maximums, and I find my minimum, okay? And then I draw my graph through those points, okay? So here we can see the graph. And again, my x-axis is in terms of pi, so I want to keep that in mind as well. Okay, so if you're using Desmos to help you do this, you can change your axes so that they are also in terms of pi, so that your graph will actually look accurate here, okay? So one thing I wanted to talk about briefly is where we get these points from, where I find them. So I have found them from, not that page, this page, right? Because I'm looking at those x-intercepts. So I've taken the x-intercepts where I started, and I've kind of changed them and tweaked them and moved them to where I needed to go. Okay, so we looked at that example, and we saw this example, right? Because I'm starting at my intercepts, and I'm moving them. Okay, so now here are a few that I want you to try and graph. First, you have to find your amplitude, your period, your horizontal shift, and your vertical shift. And then from there, you can kind of graph and continue from there. So now we're going to change one more thing. So the only thing here I see different is this negative sign, right? We haven't had any negative signs. It does the same thing that it has in previous units. It will reflect my graph. So again, I find my amplitude, period, horizontal shift, and vertical shift. The amplitude, remember, is always going to be a positive number. It's always how far from the midline am I. So I take the absolute value of my A, which gives me 2. The period is 2 pi divided by B, which gives me 3 pi. My horizontal shift is pi over 2, and I don't have a vertical shift here. So now I have to draw my midline, which is at the x-axis, and then I find some of my points here. Okay, so here's my equation, and I go from there. So I plug in the things that I know with my shifts, and I find my points that I need. I find my maximum and my minimum, and then I'm going to go ahead and reflect my graph. So I can find my original graph first and then reflect it over the x-axis. Okay, so here's what it looks like. All right, and we were dealing with a negative 2 times the sine of 2/3 times the quantity x minus pi over 2. So I do have that shift. And we see that I do start kind of at my y-axis going down, whereas in my original parent function, it starts by going up. So that's what that reflection does to my graph. So now here are some for you to try and see how you can do. See if you can do this with and without Desmos. See if you can find all of the pieces you need before you actually graph your equation. So let's look back at our learning targets. First, we looked at some characteristics of the sine and cosine functions. Then we did all of our different transformations. We stretched and shrink, right, using our A and B. Then we used our translations, which were our H and K, and we reflected these graphs. So now that we've looked through all of these learning targets, go ahead and work on your homework for 9.4.